we have already seen that how to use the cosine similarity concept for the locality sensitive hashing. So in this lecture we will see how to use the Euclidean distance for concept for the locality sensitive hashing. So let's see. So suppose let's take this is our data plane. Suppose let's take this is our data plane. Let's take this is our data plane, and suppose and this is our plane simply that will divide it. This is our hyperplane that will divided our plane. This thing we have taken, just we have already seen this plane, and we have taken randomly by using the normal distributions, normal 0 1 distributions. We have taken randomly, and the perpendicular of this plane is simply w1 for this w1. Suppose let's take we have point like that. Suppose here we have one point x1, here we have another point x2, here we have another point x3. We have to first project this point to our plane. Suppose this project is, suppose let's take project is here x11, because of this is the first point, and for this is the first plane, pi1 plane. For this, because of these two things, we have notated this point is projection point of our x1 point is x11, and this point, these projections is called, suppose this projections is called x21, because this is the x2 point and this is the projected to our pi1 plane. This is the projections of x31, because this is the third point and it's projected to our to this pi1 plane. So simple, xij means what? Xij means projection of which point? Projections of our ith point 2 on the plane pi j. Okay, this is simple, the projections. And the locality sensitive hashing is simple. It's the based on similarity or closer point should go to the same bucket. We have already seen this thing. Similar or closer point will go to the same kind of bucket. We have already seen this thing. Sure. Similar or closer point should go to the same bucket. And this thing is one bucket, this thing is another bucket, this thing is called a bucket. We have already seen this thing. And our hash value, what will be the hash value for this? Suppose I think this will be clear, all of you. Just instead of taking this picture, if we just taken this picture horizontally, just I am taking this pi1 plane horizontally. Okay, let's see how this thing is work. So let's see, instead of taking it horizontally, instead of taking this plane this side, I am taking this plane horizontally. This is sample our pi1 plane, and let's take our projected point. I am taking here x1 x12. Suppose I am using green color. Suppose this point is simply x11 point, this point is our x21 point, this point is what? X31 point. We have taken already this point. And also you will just notice this thing, distance of d1 to is much closer than distance of d1 t. If we consider the Euclidean distance, if we consider the Euclidean distance, okay, it's better if we use the notation Euclidean distance constant, then a d12 will be much closer than d13. So in such cases, what will happen? Just first one thing we have to do, first we have to divide this whole plane to regions. I'm using to divide in red color. So just divide this whole thing into a region. Suppose this is our middle point. Suppose let's take this is our middle point. This side I am taking here one region, this is one region, this is one region, this side one region, this side one region, this side one region. Suppose this regions is, we call this regions is 1, this regions is 2, this regions is 3, this region we have labeling, just simple regions, nothing else. Don't be confused about the number. This is just notations. I'm labeling our regions, nothing. This is the label -3. I'm labeling this as region. So you will see this, just x21 x and x11 are lying in a single this region 1, and x31 are lying in a region -3 minus 3. So now the thing is how to calculate the hash value, for this edge region. So this is the main trick. So let's see. So to calculate the, suppose let's take, we are considering this point. So first let's take, I am considering the h11. So how to calculating the hash value of h11? It will be calculated simple like this. So here we have constructing, suppose if we divided our whole plane into a, suppose if we divided we divided our whole plane into a region. We divide the whole plane into a region. If we divided the whole plane into a region, so the dimensionality of our hash value will be a. Dimension of our hash value will be a. Simple. If this is 0 indexed, 1 is first index, second index, and this index will be d minus 1. Sorry, a minus 1. It will be a minus 1. It will be a minus 1 if we divided the whole region into whole plane into a regions. So what will be the value h11? So this is this is responsible for our what? This is responsible for our regions 1. This is responsible for our regions. Just I'm noting here. Here it will be a minus 1. This is simple index. And here we are notating here region. So this is first region, this is second region, third region. I think this thing will be better. Just a minute. Okay. Here I am using the notations, and because these regions will be what? These regions will be -3. These regions will be -2, -1, like this will be 1, this will be 2, something, this will be 3, like that these regions will be. So here what will be the value of this? So here are sometimes just, so if I just construct this table properly, don't be confused. So what will be the value here? 1, its value will be 2, its value will be 3. So just to remove this one. And this value will be a minus 1. Okay. So what will be the h11? Just see this thing. So the pi1 plane, for this plane, for this plane, this value will be lie on the region, on these regions, first regions. So here this value will be 1. Means for our first point, ask for this plane, for this pi1 plane, this value, this point will be lie on these regions, first regions. So this value will be lie on this region, first region. So what we will do is simply, we are simply just rewrite this plane to horizontally. I am just doing this, I am just redraw this plane horizontally here, nothing else. Suppose let's take, we have randomly selected, we have randomly built such kind of M plates. Let we build, we make, suppose let we make a randomly M such kind of plane. We build such kind of M planes we have built. So and for H planes we have divided H plane in A classes, and we divide H plane into A region, into A regions. So now what will be the hash value? What will be the hash value of H point? This is the questions. So the suppose let's take, I am taking here x11 point, x11 point I am taking here. So what will be the hash value of x11? So how much plane we have taken? So our number of planes here, we have taken number of M. So this hash value will be M dimensional for this plane. Suppose let's take, we have considered M plane, randomly make. So this is the for responsible for first plane, means I am denoting for pi1. This is responsible for pi2. This is responsible for pi3. This is responsible for pi m. Okay, so now let's see x11. Now let's see x11 lies on which plane? In pi 1 plane is which regions it is lie. So in pi plane, in pi 1 plane, in it is lie on the first region. So this value will be now here, this value will be 1. Pi 1 plane, this is be lie on this plane. Similarly for pi 2 plane, if this lie on the suppose just draw the same thing, just I am draw the pi 2 plane again. This is the pi 2 plane. Suppose let's take, this is x2 1 point, this is the x1 point, and this is the simple x3 1 point. And similarly we divided this pair into A regions, into suppose A region. Suppose I am dividing this thing. This is our first region, this is the second region, this is will be the third region, this is will be the -1, this will be -2, like that, -3. This is the pi 2. So in pi 2 plane, what will be the value? Suppose let's take, suppose I'm suppose for such time I am changing this now. It will be better for our understanding. Suppose let's take, it's 1, it's 2, it's 3, it's 4, it's 5 region, it's 6 region. This is the region number, and this is the region number for the pi 1 plane. This is the region number of the pi 2 plane, and we divided H plane into A regions. So this value will be now what? In the pi 2 regions, this value will be x1.4. This value will be now 4. So now the for each cell of the hash value, this value will be what? So this value will be coming from, this value will be coming from any value from one, from the this value will be any value of the number value between, Simple, it is any value of between the class level, any value between 1 to the class level, any value of class levels. This thing will be any value of the class levels. It is a simple class level, any value will be class level. Okay, now this thing will be what? So now we are interested to calculate the hash value of x31. Just see what will be the hash value of x31. So this value will be, what will be the value of x31? This value will be like that. Pi1, pi2, pi3, im. So pi1, in pi1 plane, just see this -3. This will be -3. In pi2 plane, and x13 is lying on 2. So similarly, we can construct the h value. But the main difference between the, if we just take the main difference is what? So the main difference is the cosine similarity LSH and the, so the main difference, if we just consider, if we just remember the cosine similarity of LSH, then this hash value will be either +1 or it is -1. Okay, this hash value either +1 or it is -1. But Euclidean, but if you consider the Euclidean similarity, Euclidean distance LSH, local sensitive hashing, then this value will be the simple class level. This value will be simple the class level. Okay, this is the main difference of the cosine similarity and the Euclidean distance. Cosine similarity LSH and the Euclidean distance LSH. This is the main differences. Okay, nothing else. So we'll see, this is the main difference between cosine similarity and Euclidean distance, cosine similarity LSH and Euclidean distance LSH. Now let's see, if we just calculated the value of a hash value of the x or 21, just calculated the hash value of x21, this will be like that. This will be like that. So the first value for pi1 the x2, this is will be 4. For the pi1, but just see the pi1 plane, this value will be 1. For pi2 plane, this value will be 4. So similarly, so just see this, if 2 points are closer, then their hash value are similar. The distance of this hash value will be closer. So just if you just count the Euclidean distance from hx1 to hx11 to hx21, it will be closer. So the conclusion is that 2 points that have the same region for a plane pi I, then for if it, you just to see that for 2 points that will be is the same regions for a plane pi I, then the distance will be, for just see this, x11 and x21, 2 points that have the same regions for a plane pi I, then their distance means I am calling here Euclidean distance will be closer. I think you have understand this thing. Okay, now let's see. Now they have another problem. So what is the problem? So let's see. So just see the problem first graphically, then we will discuss them step by step. Suppose let's take, this is our data sets and this is our data point like that. Suppose this is our 1 point x1, suppose let's this point is x2, suppose let's this point this point is x3, this point is x3. Now we just, this is pi 1 plane. Suppose let's take this is another plane pi 2. Both the planes are perpendicular. Suppose, and just I'm considering this plane randomly. Each plane are considering randomly. Okay, suppose first I'm projecting the edge data point to the to first pi 1 plane, to the pi 1 plane. I'm projecting the edge data point. So this point will be here. So what will be this point? This point will be x11. Now I am projecting the x2 data point from this plane pi u. x12. Similarly for this point, x13. Okay, just I am projecting each point on the plane pi 1. So just you see, if you just see Euclidean distance of dx12 are more larger than distance of x13. This is the simple. Just if you taking the Euclidean distance from x12 and x13, so the x12 will be larger. But here, when we projecting there, when the projecting, then the hash value distance on this plane pi 1 will be closer. Here, this is the main problem. But the distance of hash value of x11 and x12 is much lower than the distance of x1, x12, 11 and 13. This is the main major issue. This is the main major issue. But because of that, just if you just divided this plane, suppose let's take divided this plane in such region. Because of these 2 points are lie on the same regions, so their hash value of this distance of the hash value will be like that, closer, and the distance of the hash value of this one, so this is the main problem. Actually this point are the further, but this hash value is closer. Okay, how to resolve this problem? Because just see this thing, how to resolve this problem. To resolve this problem, we have now considering the again another, because we have each time we have changing the hyperplane. Just in previous lecture, is just cosine. In the case of cosine similarity, we have seen that we have considerably L times in generated the number of hyperplanes, and we are considering the L number of hash value for each functions. So suppose let's take its hash value is ha1 of this point, of this x value. This is its hash value is h2 of x. So we are generating every plane randomly. So if we just projected everything, if we just projected this plane, I am taking here orange, I'm just projecting here this plane on this. Suppose first I am projecting x2 plane on this plane, then I am projecting x3 plane on this plane. Now I am projecting x3 planes like will be like that. So on this plane, what will be the value? On this plane, this value will be x3 to this value just projected here. This value will be x3, that is 1 point and second plane, and this value will be what? This value will be x plane number what? X first point number 2, plane number 2. Okay, x plane 2.2, I think this will be 2 plane 2.1. This value will be plane 2.1. I think I am sticks also here. This value will be plane 2.3. this value. So just now just see this thing. Now if we just divide this pi 2 plane in these some regions, in this plane x1 and x1 and x3 will be lie on the same regions, but x2 are lie on the different regions. Okay, because we are at the end of the day we have taken the calculator, taken the union of the age has value. So because of this, I am randomly repeating this thing, we can easily solve this issue. So but the hash value for hash 1 value, it will be the main issue, but the distance of the, I'm taking here another color, but the distance has two value of the distance, and so what has two of, I think I have to take this thing, and h of distance of hash values, no? I think this one is okay. Now it is okay. So now it has two value of this point x x21 x23 step in it, h21 h23 has value of 23, and then I am taking the distance of, so this distance will be now closer, has value of what, has value of 1 means 2 1, has value of 2 1, and has value of 2 2 2 2. Okay, so sorry for that. And I am taking this Euclidean distance, this distance also I am clear, then it will be better. So this distance will be h1, this is also h1, just h1, just this is also h1, and the distance of h1 x11 and x12, similarly for h1 of x11 comma h1 of x13. I think it is okay. So just simple, by using the another plane, this problem is removed. This problem is removed. This problem is removed by using this plane. I think you have understand. I think you have understand this thing issue. Okay, by simple using the, because you have randomly chosen this plane. So if some plane, if for some plane this is misclassified, by another plane it will be properly classified, because you have chosen this plane randomly. Okay, so because of this, because here I am taking the randomly chosen this plane, so LHS not always give the perfect answer. As starting of the LHS for similar cosine similarity, we also called LHS is a probabilistic algorithms. Simply it is a, so LHS is not perfect always, is not perfect always. So simple, because why, because it's a probabilistic or randomized algorithm. Simple, it is a probabilistic or it is a simple randomized algorithms. Okay, so this I am not proving this why this thing. I think you have geometrically understand this thing why actually this is because of I have choosing this hyperplane randomly. So if you just interest to prove this mathematically, I'm not coming to the proof part of these algorithms. If you are interested, just google it, or just google it, or search it on YouTube. You can easily find it. There are very kind of lectures and very kind of articles on this thing. I'm not going to this proof of this theorem. Okay, so now this thing is that the why, if this is not given the always perfect letter, why I am using this LSHM. LSA is locality sensitive hashing. This is because of the locality sensitive hashing. Main advantage is that it can easily handle the large dimensionality of data. If we have large dimensionality of data, it locality sensitive hashing easily can handle this thing. So it can extensively use in computer visions, that is in 2D graphics. When we are considering the 2D graphics, there's actually we have taken the distance means. So in computer visions, in computer vision, these algorithms are extensively useful. Extensively this algorithm is useful only for computer visions, but in machine learning perspectives, for large to handle the large dimensional data sets, that's not a useful one. And because of its probabilistic interpretations, because of its probabilistic output randomized, because it's a random, it is a randomized algorithms. I think the main idea I want to give you just idea of the locality sensitive hashims, how these things is actually work in KNN. Okay, I think you have understand both perspective, from Euclidean distance perspective as well as from the cosine distance perspective. Both are the same thing, but just visualizations in different directions. In cosine similarity, we have taken the angular similarity. I am measuring the angular similarity, but in Euclidean distance similarity, we have the distances through the Euclidean distance formula. This is the one thing, but the thing is actually the thing is similar. For both the cases, we have making the hash functions for cosine similarity as well as the for Euclidean. At the end of the day, we have constructed hash functions, and corresponding to the hash value, we have decided our neighbor point. And to avoid I have to avoid this kind of problem. Just I am seeing this thing for Euclidean distance, as well as we have see this kind of neighbor problem for Euclidean distance, for cosine similarity distance. So to avoid this problem, we are repeating this thing for L number of times randomly to avoid these things. And after that, we are taking the union of all the hash values, and then we can calculate it easily, this thing. That's similar. Okay, I think the main concept of this lecture is clear, and the motto of this lecture, I think it is clear, all of you. Although if you have any problem, please comment below. I'm trying to make this lecture again as I can do it simple as possible. Okay.